Okay, today is part 2 of materials. We're talking about transparency, transmission, refraction. You will need to download the Lecture7 myscene.zip if you have not done so already. We are going to be adding additional glass bottles into the interior scene. This is required for turn-ins for Project 6, because there wasn't enough glass in it. So we added more glass. There's plenty of glass in the exterior scene, so you don't have to worry about that one. But it will add in a rectangular bottle, something called a Klein bottle, and an hourglass shaped bottle. Kind of classic, old-timey bottle shapes, except for the Klein bottle. That's a fairly new addition to bottle making. Looks very scientific, in fact it is. All right, so just a reminder, I'm available for help by appointment if it is outside of the 10 to 4 block on Tuesdays and Thursdays. Just message me, send me an email so I can make sure that I'm there. Because I do have other meetings and other stuff that we get pulled to. Don't forget the research discussion is due tonight. If you are not using EBSCO or one of the approved online search or let's say research resources like Game Sutra or the International Game Studies, make sure that you send me a link so I can take a look at it. All right, transmission, refraction, transparency. The index of refraction is very important. It tells our material how to behave, and then how the MIA material works with refractions. Okay, reminder again, public service note, research discussion. There we go. Okay, now, when we talk about transparency, refractions, the first thing we need to talk about too is something called transmission. That is when a light ray passes through a surface. Now, the technical term for that transmission, or the technical description, would be a light ray that passes through a surface and is not refracted or bent as it passes through. All right, so the way that is possible to happen, and the way that it does happen, is a light ray. We're talking about a single ray, not a whole bunch of rays or photons coming in at once. We're talking about a single light ray. If it hits a very clear surface or goes through a transparent medium perpendicular to the surface direction, and it passes through unobstructed, that is transmission. You're transmitting energy through a surface. All right, examples of things that can act as transmission recipients would be clean air. Air that doesn't have too much humidity in it, because humidity, moisture, that will bend or refract light. Dust particles, that will do the same thing. And clear glass. Those are common materials that can transmit light. Right, so that light ray must hit the surface, for example, clean glass, clear glass, at a perpendicular angle. Identical to what else is on the surface that's perpendicular? All you modelers out there. You guys rely on when you model to make sure everything is okay on the surface of your model. Before you start putting textures on it, before you start putting UVs on it. Normal. Your surface normal, remember, is going to be perpendicular to the surface direction. You have compound curvature. Surface normals will follow that curvature all the way around and remain perpendicular to the surface. Remember, your polygons are what shape? The ones you guys modeled. Square, right? We do quad. So they're teeny tiny little flat surfaces. And it's only when we send it to render or we send it to another program or a game engine where it has to be triangulated. You guys know about triangles, right? All these are triangles. Now, refraction occurs when we have what's called an incident light ray. That means any ray that does not hit the surface at a perpendicular angle. Okay? If we have the same surface, glass for instance, our incident ray, which is anything other than perpendicular or 90 degrees to the surface, when it hits it, it will pass through, and depending on how thick the surface is, what the surface is made of, it will bend or refract accordingly. If it's not transparent, what happens to the ray? It doesn't go through, but what happens to it? Bounces off, right? So when it is transparent, the ray will pass through. How far it bends, again, how thick the glass is, what kind of glass it is, if it is glass or some other transparent material. Right, pretty simple to understand. Right, now we get into the why of materials and why you guys build things the way they are in the real world. You guys have all built something similar to this one class. Right, usually start with NURBS curves, you go up, start probably somewhere in the middle here, go up all the way around halfway, or you start down here, work your way up. When you're done halfway, what do? Revolve it. Right? Revolve it, output set 4 polys, case done. All set. Right, so the reason we have you build inner and outer surfaces here is because while in CG, in the viewport, this looks like air to us, when you assign a material to it, the material describes this space in between the inner and the outer surfaces of your shape. That makes sense. Right? That is not considered empty space. When you have a material assigned to it, that is considered solid. Depending on what you have it, assigned to it, it will be treated accordingly when something hits it, when a ray hits it, for example. Okay, so when we work with glass, we assign a material to it, and we give it all the properties of glass. MIA material X, that's fairly simple. Arnold is fairly simple. Rendered in is fairly simple. It is almost the same identical process in any advanced renderer that has materials like that. Okay, you basically tell the material, your glass, you give it an index of refraction number, you give it a color, you tell it how to behave as far as how much transparency there is. That's all fairly common, fairly simple, actually pretty easy to understand. Now, when we go to render, we have to figure out how many surfaces does a ray need to go through on its journey. Right? Just like we had to figure out in the helix and the sphere, how many times did we have to have reflections back and forth until we didn't care anymore before it got so small or unnoticeable we didn't need to calculate more reflection. Right, so an ordinary wine glass, water glass, bottle is going to have 4 surfaces. Okay, you have an outer surface, you've got the inner surface. If this area is empty, it's air. Don't have to worry about that. Light ray or shadow ray or camera ray is going to hit the inner surface again, outer surface, and continue on its way. So we need to tell the render setting, hey, you've got to have at least 4 transmission rays in order for us to describe this material that's transparent properly. If we don't, the rays will stop and your render will not look very accurate. You'll be able to tell something will look weird. It'll look too solid rather than, thin wall of glass with some air in it. So if you have simple shapes like this in your scene, and those shapes do not overlap, you don't have glass overlapping glass, then you can probably get away with having 4 transmission rays globally in your scene. Does that part make sense? Now you guys have all seen images where the big thing a few years ago used to be Coke bottles with Coke in it, and they would have them like 24 of them all lined up, and they would all be in front of each other, and you'd have to be able to see through them to a certain point. Right? That gets to be very expensive, because globally we have to figure out if you have a glass in front of another glass, the camera ray, the shadow ray, the ray tracing, transparency, transmission ray has to go through not just the 4 surfaces, but on its journey it's going to hit an additional glass. So it's going to have an extra 4. So what's the total going to be globally that you would need to have as far as transmission rate? 8. So basically you just take the number that's there, double it. Now, if you had 4 glasses in front of each other, right? They're all lined up and you have to look all the way through, what would you need? 16. 16, exactly. Okay, so that's simple. When there's nothing in your glass, you're good to go. It's pretty simple to figure out. Now, if you have water, you have wine, you have soda, you have milk, you have something inside the glass, you need to calculate an extra 2 surfaces. And I'll explain why 2. Hey, first off, before I do that, anybody know why just 2? Why not another 4?
From the inside wall to the other side of the inside.
Right. So it'd be, once it exits here, it would hit the shape that's in here. We'd go through, we consider that shape solid, or the same material all the way till it got to the other end. Exactly. Did they show you guys how to model liquid in modeling? Other than doing a fluid simulation or dynamics? What's that?
They didn't do that.
No, okay, I didn't think so. But there is easier ways to do it than fluid simulation if you're doing a still. One of the easiest ways I used to do it was I would select the faces inside the glass. So for example, if I wanted my liquid to go up to here, I would select the faces that went up to there all the way inside, select them all the way around, duplicate them, scale them in ever so slightly so they're not on the same plane or 3D space as the wall, scale it in, and then you cap off the top. So now you've got a shape that perfectly matches whatever shape your container is, whether it's simple or it's complex. That's a very easy, kind of simple way to do it. Especially if you don't have animation, you don't have to worry about liquid tilting or, getting knocked over and having to simulate particles and water fluid dynamics. So that's a very simple thing you can do. Now, if you have liquid, the liquid will get its own material regardless of the renderer you use, regardless of, what software package you're using. It's going to have its own material and it's going to have its own description. It has to be water. It's going to have a different set of numbers to describe it to the ray. Those numbers are going to be the index of refraction. All right, before I go on, does anybody have any questions? Anything not clear so far? Please ask. Okay, don't forget that the MIA Material X uses conservation of energy. We are now adding in transparency. So once we start to dial up the transparency, it's going to steal energy directly from which part of the material first? Diffuse, exactly. Remember, that's the first to go. That's the first thing lined up against the wall during the revolution. So, diffuse, then it starts to steal a little bit. If there's a lot of energy in the reflection, it'll steal some energy from there as well. All right, so the more refractions we add, we steal energy from the diffuse first, reflectivity second. Okay, so the controls that we have in the MIA material X, these are more or less standard. Wherever you go, whatever you're using. The only thing that may be different is glossiness, which describes surface roughness, might be called roughness in another package. But you will still have index of refraction, color of some type, and some kind of transparency or weight control. Sometimes they will call it weight rather than, transparency. Okay, so this number right here, this tells the ray what kind of material it is passing through. That number is standardized. That's not a made-up Maya number or a mental ray number. That is right out of the physics playbook. In fact, if you Google any university with a physics department and say index of refraction, they will give you a whole rundown of pretty much whatever they consider to be important. In fact, you can get anything from air all the way through to steel, copper, brass. Yes, they all have some kind of index of refraction. Right? So that number, not arbitrary, a number really is how the MIA material X, mental ray, Renderman, Arnold, V-ray materials, game engine PBR materials, that's how they try to maintain physical accuracy. By using real world numbers and trying to simulate what happens to rays in the real world. All right, color. For us, that is going to be the color of our transparent material. For instance, the color for glass is going to come from here. The color for wine, primarily, is going to come from here. Okay, transparency. Most of the time, if you're doing water, you're doing air. Air. Hardly anybody who does air because you can't see it. Doesn't cast a shadow usually. Water, a diamond, acrylic, alcohol, glass, right? They will all have some level of transparency. To start with, most of the time you can dial that all the way up to 1, which is 100%. Yes, I know technically some glass is not completely pure and completely transparent, but you can deal with that usually in the color because those impurities can usually be seen physically. But 1.0, that's the place to start. Glossiness. What happens when we use glossiness in reflectivity? What did it do to our reflection? Made them nice and blurry. Okay. What do you think it's going to do in the refraction section? It is going to blur the transparency or the transparent rays that are going through. When you blur transparency or you refract it or spread it out and diffuse it, you're going to create an effect very similar to frosted glass. Because frosted glass is either chemically etched or some kind of material, diamond dust, sand dust. They will etch glass, sometimes called privacy glass. Another example of something that might look frosted also would be you have a glass of water, it's got ice cubes in it, or it's cold, it's warm outside, what happens to the outside of the glass? Condensation. And that causes very microscopic beads of water all around the glass that makes it look frosted. Right. Does this make sense so far? Okay, so a couple of renders using a simple IBL, plane and sphere, interior environment, single light source, just to show what happens to reflectivity and transparency as we change the index of refraction number. Okay, so air has an index of refraction number of 1.0. Yes, I know air does not cast a shadow, but if I didn't have shadows on, you wouldn't believe I had a sphere here. I could just put out a scene and go, yeah, there's air there, everywhere. All right, so same sphere, same place, every single render. The only thing I changed was the index of refraction. Water. Average water, 1.3, 1.33. Believe it or not, these numbers are actually inside the material in the little yellow hint bars that pop up when you go put your mouse above an attribute. All right. Glass. This is common average production glass. They call it crown glass. That is 1.52. Or somewhere between 1.5, 1.52, maybe a little higher. That's the range for glass. Notice what happens to the reflectivity and what happens to the transparency as we increase it. We get into a diamond, light bends a lot more. Also, the reflections become a lot more prominent the higher the number. That means the material is denser. We're telling the material to tell the ray it's denser so that it behaves like it would more or less in the real world. All right, so just 4 common index of refraction numbers. All right, so color. You change the color of the transparent material. That's how we're going to start making colored glass. Trick to colored glass, just like light, is keep the saturation on the low side. In the refraction color, you probably want to start with your saturation somewhere around 0.2. Anything higher than that, it will get too dark. It'll be hard to see through. The rays will have trouble getting through. 0.2 for saturation, yes. Just like light. You want to keep it relatively pure and keep the color dominance kind of low. Okay, glossiness refraction. When we started blurring out reflections, what happened to render time? Yeah, it went up, right? Even if you're using unified sampling at one of the low settings, it's still going to calculate and show more in an area that it sees needs cleanup. Same thing here with refraction glossiness. As you drop it down, we diffuse or disperse those transparency rays so it blurs the transparency. Again, creating that frosted glass look, but killing your render time. Right? It kills it more than reflectivity, because not only is it being diffused, but it's being diffused as it passes through a surface. Wow, somebody left their car horn on. All right, again, refraction glossiness will add render time, big render time. So this is something that you want to watch and make sure you don't overuse, especially if it's not needed. Now, the one control we did not talk about in the BRDF on Monday was this thing called use Fresnel reflection. Okay, everybody say this word with me. Fresnel. Thank you. No S. If you say Fresnel, you will be laughed out of whatever job interview you're going into. They will laugh so hard they will have to excuse themselves to go to the bathroom. Okay, Fresnel, it's French. Fresnel effect. Look it up if you're not sure. Right, use Fresnel reflections. What does that mean for us with VRDF? Simply put, if this switch is turned off like it was last time, we have manual control over 0 degree and 90 degree reflectivity, right? That's how we made mirror, chrome, very reflective surfaces. As soon as we turn on use Fresnel reflections, this is disabled. And all reflectivity information is controlled by this number. Lord of the Rings, right here. Index of refraction. That number not only tells the ray what kind of material it's going through, it's also going to tell it how to behave as far as reflectivity goes. So if you want to make really accurate looking glass, water, plastics, diamond, any kind of transparent surface, I'd say 95% of the time you want to turn on use Fresnel reflection. Now, there are exceptions, just like everything else. There are certain glass types that are coated, that have some kind of chemical treatment on them that make them more reflective than normal glass. So in that case, you would probably want to use manual reflectivity. And just when you thought it was safe to get in the water again, not only are we figuring out reflectivity globally, but now we're figuring out transmission. Right, so when we were playing around with the helix and sphere last lecture, what did we come up for as a number that was acceptable for all that self-reflectivity on the helix? 5, right? So somewhere between 4 and 5 is a good place to start for reflectivity if you're not sure how much you need. Because that will solve most of your average problems. As far as transmission goes, 4 will probably solve most of your common glass issues, right? If you got a water glass, you probably have 4 surfaces the ray has to pass through. So remember, reflection plus transmission is going to equal max trace depth. Now, there are going to be more exceptions to transparency and refraction and glass than there are with reflectivity. For example, we have such a case with the bottles you guys are going to import. All right, this Klein bottle, until modern 19th century manufacturing, this was impossible for a traditional glass blower to make. You guys have all seen videos, right, or attended glass blowing workshops, right? You get a blob of molten glass, put it on a really long tube, you start blowing it, you start rolling it, you shape it with tools. Okay, it is virtually impossible for a glass blower to be able to take the neck of a bottle and put it into itself and then have that neck become the opening at the bottom of the bottle. It's not until we have injection molding that that was possible. This was basically a mathematical enigma that they knew was possible to make, but couldn't do it with traditional methods. So now that we have injection molding, right? You get a mold, you cram stuff in there under pressure, it goes through all the channels inside the mold, fills it up, it hardens properly, you take it out, and it's done. So the Klein bottle works very simply. The bottom is the opening where you fill the bottle up, right? Liquid goes through here, comes up around here, and then gets distributed into the large chamber. They actually sell these on the internet now in plastic, and they make really fun party glasses to give your friend. Because it's like kind of watching a dog try to get the peanut butter off the roof of its mouth. Because they know there's liquid in there, but they can't get to it. Because you can turn it, you might be able to suck some of it out if you turn it upside down, you keep turning it, revolving it. And then make special bending straws you can then give them after you're sufficiently used. Right, but what this means for us is not only do we have 4 normal surfaces, what happens to the interior next? What does that do to us? Now we need 8. So what we have to do is configure globally for the worst case scenario. So with the Klein bottle, globally, we would have to crank up transmissions to 8. What would that do to our trace depth? We go to 12, exactly. All right, so nothing here in the rectangular bottle. It's fairly simple, no overlapping glass surfaces. When we get into the hourglass, you will find the top of the bottle has a mushroom lip on it. That means it overlaps itself a little bit at the very top, which means we would also need 8 for that bottle too. Now the reason I mention this is because globally we can figure for the worst, but on a material by material basis, we can tell the mental ray material how to limit itself so it doesn't stand there and try and crank out unused transparency rays or refraction rays. Does that make sense? Any questions about that so far? Anybody not clear on anything, please? Okay, so this is globally. Remember, this is under the quality tab under trace depth. We're not done. What we have to do now is go into shadows. If we have configured for the worst case scenario of 4 reflections, 8 transmission, we have 12 for max trace depth. What gets plugged in here? What is it? 12, exactly. You need 12 shadow rays. Why? Because shadow rays, unlike ray tracing rays, are not broken up between reflections and refraction. They're global. But you need the shadow ray to know how many surfaces it has to be visible through, or how many reflective surfaces it has to be visible on. So we need the same global number there. And now we're back to lights also. Don't forget our lights need to broadcast enough shadow information as well. Right? So globally we set up for the worst case scenario. In our lights, we set up for the worst case scenario. So in the material we can kind of dial down a little bit. Right, so ray depth limit would get what? 12 as well, right. What will happen is, I'm going to show you guys when I do a demo, that if you do not have enough shadows, you do not have enough ray depth limit, your materials, when you try to look through them, look for shadows, it's going to do weird things to your environment. Okay, this is a checklist for your benefit on common steps to make glass. I also have this as a download, as a JPEG. If you haven't downloaded it, download it. Etch it in your brain. Like I said, This part down here, 7, 8, 9, that's generally mental ray, renderer specific, but most of the other stuff is going to be kind of common knowledge for most advanced materials. The first thing you're going to want to do is assign a new material to your glass or whatever you're trying to make. Okay, change the index of refraction so that it matches the type of material, whether it happens to be plastic, alcohol, liquid, glass, it doesn't matter. Transparency, for glass we start off transparency of 1. The color, if you have clear glass, the color is going to be white. If you have colored glass, then we'll sample the color from the reference and adjust accordingly. And all this is in the refraction color. Now, when we start to have dark glass, something like a dark green wine bottle, dark amber, dark blue, there are some things that we need to do in order to get that dark color and still have it be transparent. One of the next things you're going to do, turn on, use Fresnel reflections, because you want reflectivity controlled by index of refraction. Notice at points you should be rendering to see what it looks like. Am I on the right track? Did I forget something? All right, then you're going to go in, change your global settings in 7 and 8. Trace depth, figure out what the reflectivity is, what the transmission is, what the trace depth is, the max trace depth. Then you're going to go into the quality section for shadows. Then you're going to go into your lights, and you're going to render. And if you've got empty glass, you've got glass that light can get through and bounce around in, there's a section in the MIA Material X under Advanced Reflections called Skip Reflections on the Inside. That is turned on by default. That means Mental Ray is trying to save you some time by not calculating reflections inside a glass vase, or a glass jar, or a glass bottle. If it's clear, we definitely want that turned off, because we want reflectivity bouncing around inside. Okay. So, if you guys want to follow along, we're going to be working on the interior scene. We're going to be using the download Lecture7 My Scene file. Inside there is glass bottles lecture7.ma. The extra bottles are scaled. They are positioned. When you import them, they drop right into their proper location. There is no need to do anything else. If you move them around, we're going to look at it and go, what were you doing? Don't do that. So let me start off by firing up Maya. And we'll do a couple of the bottles inside the interior scene. Then we'll switch over to the exterior scene. And we'll do the wine glass, wine, maybe the bottle too. First thing I'm going to do is set my project to my interior scene. All right, so I've got some materials in here. So the first thing I'm going to do is import the necessary Lecture 7 files. You guys know how to import stuff, right? Pretty simple. You do that in modeling all the time. Build assets, then you bring all your assets into a finalized scene. So I'm going to go File, Import. There's my glass bottles, Lecture 7, Import. Notice that they drop in the proper location. All right, so first thing I'm going to start off with is the vase. Why? Because if you take a look inside the Lesson 7 activity, the glass vase is going to be transparent. Clear glass. And that's how it should look for turn-in for Project 6. The other 3 bottles, you guys can give them whatever color you want as long as you have reference for that color. Don't really need reference for a clear bottle because I think we pretty much have that etched in our brain what a clear bottle looks like. And there's really only one way to make a real clear bottle, so. But we will be looking for reference and look development for colored glass. All right, first thing I'm going to do, assign a brand new material to the vase. Oh, shoot. All right, so if you pull up that checklist, first thing we did was assign a new material. What's the second? Anybody got it downloaded? Yep, change the index of refraction. So the first thing we want to do is go down to the refraction section. If you hover above the index of refraction, generally you will get a yellow hint bar that pops up. It'll give you average stuff like air, water, alcohol, quartz, crown glass, a diamond, average refractive numbers that are used all the time. Right, so crown glass, 1.52. Next, transparency. Turn it up. You can see in your little sample swatch, starts to look transparent, starts to look like those little checker pattern squares behind it are getting distorted. They're bending. Okay, so index of refraction. The color, it's going to be white because it's clear. Transparency's up. What's next? What was it? Yes, turn on use Fresnel reflections, which is down under the BRDF section. Turn that on. Now all the reflectivity is controlled by the index of refraction number. Now what do we do? Render. Yeah, it's always a good idea, render. And check your render settings. So there, ooh, that's too high. Way too high. Okay. So we knock our render settings so it renders sometime today. I'm going to do a screen or a camera grab. All right, so we've got a vase. Sort of looks like we have refraction when we look through it. Looks a little funky. We'll work on that. What's next after rendering? Okay. Exactly. We have to go into the render settings. Okay, by default, 4 reflections, 4 transmissions, 8 max trace depth. Perfect, no problems. Got the minimum requirements for this vase. Won't be too bad. How many of you have a table that is a light color? Okay. So, if I make my table a light color to match yours, keep image, render. Whoa. How come it looked normal when I had a dark table and now it looks like the surface of the sun? Or I've got like dark matter in there or something. What's going on with that? It's broken. Call the Maya help desk. Call Autodesk. They will laugh at you. Put mute on your speaker so we don't have to hear it. Whoever's recording, I've got everything on mute here. Turn the volume down. All right, so we need to figure out what's going on. Why does it look okay here, but when I have a light colored material, it's terrible? Let's go through the checklist just to see if we missed anything. All right, so we have enough for now. We have enough trace depth numbers, right? 4 reflections, 4 transmission, 8 for max trace depth. What do we need to do next? What is it? Shadows. Where do I find this alleged shadows? Legacy options. Thank you. Shadows. What are my shadows set to? 2. What do I need them to be? 8. Yep. All right. So that's good. Let's keep image. See if that helped. Crap. No, it didn't. All right. So we have a non-magical moment. What is it? Reflections? Well, we've got reflections at 4, but it's the table behind the vase that's causing it. We've got enough shadows. What do we need to check next? Right. Ray depth limit. Where do I find that at? In the light. How many lights do I have in here? Well, if it's daytime, you probably only have 2. If it's nighttime, you got more. All right, so first thing I'm going to do is take a look at my sun, which is directional light. And where do I find ray depth limit? Under shadows. Ray trace shadows, right there. All right, so what do I need to plug in here? 8. Okay, let's see. Did that do it completely? Oh, looks pretty good. I have another light in here too, correct? Yes. Even though it may look okay here, I really need to do that other light as well, because while it may not affect this glass, it will affect other glass that's nearby. So for example, that hourglass shape that's on the little end table next to the sofa is closer to the area light. All right, so the area light, we need to have the same number in. Right, but we have these dark edges now of our clear happy vase, happy little vase. What do we need to do now? Turn off skip reflections, and I'm going to find that where? Okay, under advanced reflections, but is it in light? Is it in render settings? Where is it? In the material. Very good. So you have to select the material you're in. Under reflection, remember, REFL, read past the first 3 letters. Under that is advanced reflection. You want to turn off skip reflection on inside. Keep image, re-render. That looks more like glass. All right, fairly simple formula for clear glass, right? Pretty straight ahead. You can make clear glass all day. Let's go in and work on, all right, well, I'm not going to pick it. You guys pick it. Which one do you want to do next? Do you want to do the climb bottle, the rectangle, or the hourglass? Climb bottle, okay? Because it's weird. I agree. It's cool. We'll do that. Now we need to figure out, well, it's got to be color, because we're only going to have one clear object in our scene. That's going to be the vase. So we need to get some reference for color bottles. And generally, go to your favorite search engine. Type in color glass bottles. Go down under images. Ooh, pretty. Now, I know that when you're doing look development, we always tell you, get look development that's in an environment kind of the way that you want it to be. Like interior day, you want to have it near a window, it want to be sunny. When you're trying to get reference or you're trying to sample color for glass, believe it or not, a white background works good because you get a purer color sample when you go to use the eyedropper to color pick. You want to avoid interior shots. Right? You want to try and find nice neutral shots. Size doesn't really matter as long as you have a nice clear image and you can get a good sample from the color. Right, so for example, I could use this as reference for what I want to do, but then when I want to sample that red bottle all the way in the back, I could use this as reference. Or if I want to use the orange bottle here, I might use this as reference, or I might find more reference of different color bottles that I can then pick from. Make sure that you're getting actual, to the best of your knowledge, actual photos. Because you don't want somebody else's CG interpretation of reality. All right, so I'm going to open this one up so I can grab the image. This one looks fairly realistic. Oh, don't want to share it. So let's save it out. I'm going to put it on my desktop for now. That looks like some kind of weird death thing. Who would have bottles like that? That just begs to be broken. I know, somebody who doesn't have friends. Because if you have any friends or you have kids, those things are busted. Right. What you're trying to find also for your reference is empty bottles. All of our bottles are empty. So I'm going to go with my reference. What I'm going to do is load it into my render view. Just like you guys loaded in reference images when you were color picking for materials. Okay, going to keep image. So what color should we make the Klein bottle? Right, I heard purple. I heard yellow. Blue, red, yellow. All right, purple. Raise your hand. Keep your hand up so I can't count that fast. Red. Blue. Green. That's two, you don't count. Yellow. Purple wins. All right, so first thing on our list, what do? Make a new material. Shift T. Assign a brand new material. Material X. Going to call this Klein bottle. Okay, next. What do? Index of refraction. It's glass, so it's still going to be 1.52. What's next? Transparency all the way up. Done. Next. Color. Right, we are going to color pick. So I'm going to click on the refraction color, get the eyedropper, try to find a nice kind of neutral area that represents, I don't want to go too much into the shadow. I'm going to stick more towards the center of the bottle. Now notice that my sample swatch looks a little milky. We'll deal with that in a second. We just want to get the color, and then I'm going to show you guys how to kind of refine it. What's next?
Use Fresnel reflection.
Turn on use Fresnel reflections. Good, done. Next.
Render.
We render. Woohoo! All right, so does that look like my reference? No. So a couple things going on here. One of them is lighting. It's not on a neutral white background. But what I can do, since I have a magical 3D camera, is rotate my camera around so that it is aimed at the window. So I can use that nice bright IBL outside as my lighter background. Now, if I do not want to wait for my clear vase to render, I can hide it, right? Control H. All right, did that help my cause? Maybe a little bit, but it's not going to win you an Oscar for best glass performance in a CG render. So, let's take a look at what happened when we color picked right from the image. What we're going to do is we are going to dissect the color. Click on it. Take a look at it. Couple of things going on here. Saturation. Anytime your saturation is very high, it is going to block some of the transparency. Right? The color is very dominant. It's going to make it difficult to be able to see through. Another thing, underneath. What's underneath saturation? Value. Lightness and darkness. Is our glass pure? No, we have introduced charcoal into it. Right? Anytime your value goes below 1, you are introducing some darkness into the color. Now, that's not a bad thing, but what it's also doing is hampering our transparency. So, here's a couple of things that we're going to do. One is, we're going to drop down the saturation. Going to drop it down. My go-to starting point that I like to do is 0.2. Sounds pretty drastic. It's going to look, not purple at all. I'm going to re-render that part. See what it looks like. Did it help my transparency? Yes, it did. So that's good news. Does it look like the reference? No, it's still dark. So, what I'm going to do now, come on, get up there. There we go. Is instead of having my value down so low, I'm going to turn it up to somewhere around 0.8. Now, what that's going to do is lighten it up, but that color really does not match this. What I'm going to do is I am also going to assign the initial purple color that I had to the diffuse. Because anytime my transparency in glass falls below 1, or my value has dark in it, or you're not getting enough transparency, energy is being added to the diffuse section. So the reason this looks a little milky up here is because any of the energy that's not transparency or reflection is getting default gray. That's going to cause it to look cloudy, milky, and not very transparent. Won't sparkle very much. So what I'm going to do is go in here. I'm going to drop in the initial color I sampled. I'm going to turn up saturation because I'm only taking a little bit of energy, and I'm going to drop the value down because I want any color coming from the diffuse to be deep and rich so that it matches my reference a little bit more. Notice what it did. Now the sample swatch looks a little closer to the reference. Let's render it out, see how it looks. Right, so that color is going to look a lot closer to my reference. So dark colors, we need to have some of the same color in the diffuse. We're going to run into this problem again when we do the exterior scene and we go for the dark wine bottle. Right, so that matches my reference a whole lot more. Does that make sense? Right, we'll do it again in the exterior. Right, but for now what I'm going to do is I'm going to zoom in closer to the Klein bottle because we have to solve a couple of things. We've got the color nailed down fairly well, but what we need to do is figure out the refraction part. Right, I'm only going to render the bottom part because I don't want to spend all day here waiting for this to render. Settings in the render setting, what was the transmission number we used? We used 4, right? What do we need to do for the Klein bottle? We need to change it to 8. Exactly. Remember, in render settings, that's a global for your entire scene, so you have to set it up for whatever the worst case scenario is. And these are low render settings with glass now chugging along happily. So you can expect your render times to double at least. Maybe triple. Shiny objects, lots of glass, equals long render time, equals patience. No streaming. Make sure you plug your computer in so you're using the high-powered graphics card. Okay, let's go into the render settings. Under trace depth, we need to adjust transmission to 8. What is our trace depth? Our max trace depth is going to be what? 112. Thank you. Whoa, not 122. Right, what do we need to do to shadows? Yep, that needs to go to 12. All right, our work here is done for now. How about lights? Yep, lights need to go to 12 too. Yeah. Especially that area light, because now we're using that as kind of a backdrop for the Klein bottle. I'm going to re-render that little section, see if that helped. Because we can't see through where that neck is. Right? It hits 4 and it stops. I'm going to pass out masks next class. Everybody puts a mask on. Right, I'm going to stop the render at this point. And it changed a little bit, but here's something you need to know. The MIA Material X is limiting how many transmission rays or refraction rays it will accept. Just like it limited our reflection rays. So we need to go into the Material X for the Klein bottle. And this is a local control. We need to go down under Advanced Refractions. Make sure it is REFR ACTION. The total number of refraction rays are set by default to 5. This number needs to be changed to what? You would think 12, but we're just dealing with refractions. 8, right. This is where the material, we can tell it exactly how many rays it needs so it doesn't waste calculation time on something it doesn't use. So while it's the same verbiage, this blows my mind also. Right? I don't know why they couldn't just name it refraction rays instead of max trace depth to confuse you with max trace depth in other places. Right? But this is under advanced refraction, just refraction rays. We set it to 8. Now when you re-render, it should be a lot more accurate, and yes, it will take longer to render. But now the material is allowing all the transparency, all the transmission, the refraction rays to go through. Now it's still, that neck inside the bottle is going to be darker because remember, color is additive, so we're adding purple and we're adding purple inside. So it is going to get darker. All right, I'm going to stop it. We can still compare with what we have here. All right, so that, all you see is reflectivity. Now you can see through it. So for the Klein bottle, we need to have 8. refraction rays inside the material itself. All right. With that information, you guys should be able to do the other two bottles in the scene without too much issue, too much drama. All about taking your time, go down the list in order. The other bottle you're going to have to deal with some extra refractions is going to be hourglass shaped bottle. Alright, so it is a noisy render because I got really super low render settings, so it renders. One last thing that we did not do is what? Yep. So under advanced reflections in the Klein bottle material, turn off skip reflections on the inside. That will allow a little extra light bouncing around inside. Make it look a little more natural, a little better. And of course it will increase your render time. So at this point, when you start working with glass and advanced reflections, it is going to be pretty much a way to do. Render in small pieces, low settings. Do you get what you want? Then try a higher quality render. Try to render full production quality for everything you're doing. Drive yourself crazy. Right, so this is without skip reflections. This is with skip reflection, or skip reflections turned off. So we're almost getting that rim light effect because it's allowing reflectivity inside to bounce around. Okay, any questions so far? Anything not clear? Yes.
That's a question. So I was trying to follow how you were about like on table, like that.
Say that again.
So for the part where you have
Oh yeah, like it's going to be shadows under landscape. The shadows, that's as long as you plug in the same number that you had for max trace set. So we had 12 in max trace set, we go down to shadows and plug 12 in. So if your lights go right down to 12. As long as those three numbers match, that will take care of the super bright nova. Behind your vein. That's probably where it's going to be. Okay, let's move into the exterior scene. This one should be actually fairly simple. A couple of little caveats with it, but all in good fun.
What? Oh.
All right, so I have some materials assigned. Turn down my render settings way low. it on the glass, even though we're going to be making this clear glass. Put it on the bottle, because I initially thought I'd have a dark green bottle, like ordinary wine bottles are. Right, my window's reflective. Remember, this is not meant to be transparent, even though it's a window. This is full sail glass. Remember, full sail glass has got a backing on it, and it doesn't really let doesn't let any transparency through on a lot of our windows. All right, it's going to be reflective. So full sail glass. Right, for the wine glass, that's going to be straightforward. Clear glass, right? Not very difficult to make. Assign a new material to that glass. There we go. All right, so if I want to make clear glass, what do I do? Yep, sign material. Yep, index of refraction. Done. Transparency. Done. BRDF, used Fresnel reflections. Very good. What? Render. What is it? All right. It's kind of a breach of protocol, but sure. Okay. Skip reflections on the inside. Once you guys do this enough, you'll know to do everything up front and then render. All right, since we're doing everything else up front, what else do we need to do? How about global settings? Got to go into the render settings. Go down under trace depth. What should that be? So good place to start reflectivity is what? 4 or 5. Pick it. Which one? 4, because they're cheap. All right. How about transmission? 4. It's a good place to start, right? We got a wine glass. Fairly simple, straightforward. 4 surfaces. How about max trace depth? 8. Yeah, there we go. What's next? Legacy options. Shadows. 8. What's next? Yep, max trace depth. Hey, fortunately, this is a simple scene. 1 light. Woohoo! So that's simple light. It goes to 8. So now, what I want to do is render it out. I'll keep image. Get rid of all the other images until Maya crashes. There we go. All right, so there is my wine glass. All sparkly from the sun. Now, what I'm going to do is I'm additionally going to re-render the shadow so I can show you what happens when you have glass and your shadow turns transparent. That's what you want. That's good. Now, our wine looks like something you would not drink, of course. It looks kind of like tar. So That's going to be the next thing we're going to tackle. What color should we make the wine? All right, who says red? White. Red wins. Now, it doesn't matter what kind of wine you have as long as you have reference for it. I heard blue. There are some blue wines out there, okay? Depending on the type of grape, maybe they've blended blueberry juice in with it. You need reference. And besides reference, you're also going to need a couple other things, like what is the index of refraction for wine? So I want red wine in glass outside. Why? Because my scene's outside. I want to see what red wine looks like out there. Okay, a couple things to avoid. This. Lots of reflectivity. Light's not really getting through that wine. This would be acceptable. That would be acceptable. That one sort of on the side. That looks like an overcast day. That looks a little odd. That one's not bad. That one's not too bad. That one's not bad, except it's got ice cubes in it. Avoid that. That's wrong. That's outside. That's outside, definitely, on the ground. So whatever you do, pick wine that's got decent lighting in it that you can actually see through. That's not bad. Try this one. Let's see. Yeah, it's usable. We'll try that one. I'm going to drop that into my desktop so I can grab it later. Okay, so we've got my reference for the wine. It's also my look development at the same time. Now, before I get started though, I need to figure out what is the index of refraction for red wine. So I'm going to go back to my favorite Google search engine here. I'm going to type in index of refraction wine. And first one comes up, difference between red wine and white wine. Okay, I'll clickbait. Yeah, sure. Guys in lab coats. It's not porno, so that's good. Because you always have to watch whenever you Google something that's an image. If there's anybody around you that you don't want them to see, always preview it first. All right, so ethanol content by density methods. Sounds serious. Scroll down. Now we're getting into different color wine, white, red. All right, that's all fine and well, but I don't see index of refraction. So I'm going to keep going down. Okay, ethanol content. Yeah, that's good. Yeah, nice, nice. All right, here it is. Down here, refractive index of wine. So we have white, we have red, we have three different whites and three different reds. All right, it looks like the red wines go anywhere from 1.339 to 1.337. All right, so we could split the difference and go, okay, 1.338. That would be index of refraction for red wine. And you notice that white wine really isn't that much different. White wine, red wine, it's roughly about the same. So, with that knowledge, I will now assign a new material to the wine geometry inside the glass. MIA material X works perfectly well. Red wine. All right, so what did we decide we were going to use for the index of refraction? 1.338, right? Somewhere in between. All right, now, believe it or not, you can actually use that fourth number. All right, 1.3381 or 94 or 9. I'm just going to keep it at 1.338. You can use 4 digits, but it will round it down to 3. It'll only give you 3 decimals. Okay, so what do we do now that we've got the index of refraction set? Color. So let's color pick. Load the reference in. What I'm going to do is I don't want to color pick from a dark area, right? I want to color pick probably closer. Remember, it's inverted because it's a reflection in liquid. So the sky's down here. It's going to probably be a little purer color to what I want. All right, going to go with that for now. That'll work. And what's next? Transparency. Yep, there we go. Notice it's got kind of that milky haze. We know where that's coming from. We can fix it. What's next? Use Fresnel reflections. Yep. Let's take a render, see what that looks like. Not bad. Sort of looks like it. Could be a little deeper, a little richer. All right, so what we can do now, notice that it's got that hazy look to it. And if we go and we click inside the actual color, we can see our value is very low. It's below 1. So anytime it's below 1, we're pulling some color in from the diffuse. So if I want that to be deeper and richer, I'm going to assign the same color, except I'm going to drop the value down even further so it really makes it deep and rich. So let me keep image, re-render that little section there. All right, so you can see it kind of got rid of that milky look, made it look a little more like this. All right, notice now what kind of shadow do we have coming from the bottle or from the wine now? So the wine, not only is it transparent, but it's also got what in it? Color. Remember, transparent colored liquids, that color will be transmitted onto the shadow too. Now you would do exactly the same thing for the bottle. Figure out whether I want a dark amber bottle, a light amber bottle, one of those light kind of bluish clear bottles, dark blue, whatever. The bottle is empty. There is no liquid inside the bottle. Now, one other thing that we did not do, which I'm not going to let this get too far. Globally, how many surfaces did we set the render up for transparency? For transmission. We now have wine inside. I heard somebody say it. How many do we need? 6. So that cranks up our max trace depth to what? 10. Also, our shadows need to go to 10. The light needs to go to 10. Going to keep image. Do I need to change the material? Here's a question. Not meant to be a trick question, but it can be tricky. No, the answer is no. Why? Because my glass, I only need 4 refraction rays for the glass itself. For the wine geometry, I only need basically 2, but 5 are the default. I can get away with that, that's fine. It's only when you've got a single object that has more than 4 surfaces do you have to worry about the material. So these are both separate materials, so I don't have to worry about increasing the refraction rate. Okay, any questions? That makes sense. You guys gonna be able to do okay? Going on? Good. Yes?
So, I've been working on some of my models where you've been demonstrating, and for the render settings, do I need to change them for each model that I do, or do I just kind of find one average?
Good questions. Remember, for the render settings, the global controls, you have to set it up for your whole team. So you find which bottle is going to need the most transmission rate. Like the Klein bottle, right? So you set up your transmission for that. Now, it happens to be the Klein bottle and the hourglass both need the same. So it works. But if you had, say, another bottle that had 3 necks in it, or 2 necks instead of 1, you'd have to set it up for a bigger number. But the Klein bottle is the worst case scenario, so set it up for that. And like we did for this scene, the worst case scenario that a ray has to pass through is 6 surfaces here.
So we set it up for the wine glass.
Well, it's not just the glass. Remember, this is liquid inside of it, so it's 2 separate surfaces, but the ray still needs to go through those 6 surfaces. So globally, we have to say, rays, you're going to hit 6 surfaces, expect to go through them. If we just said 4, then it would get halfway through the wine and go, done, and stop. And you wouldn't be able to see past it. Good question. Any others?
What are the main differences between liquid and glass?
Liquid and glass. Liquid is going to be a solid, right? Because if we took away the shape of, if we took away the glass and we were able to maintain the shape, that like a big giant water drop, that is going to be a solid material type. So there are no inner and outer walls for the surface. Since it's transparent, it still gets transparency, it still gets set up for transparency. If you're doing something like liquid mercury, something I know is not transparent. If you had a glass with liquid mercury in it, you would assign a material to that and give it all the properties of mercury, which is mostly what? Reflective. It's like chrome, sort of. So you would make it look like that. But for the most part, water, soda, wine, all that juice, that's more or less going to be set up sort of like glass. Different index of refraction number, color will be different, but it's set sort of the same way. Any other questions? Good stuff. Keep going. Okay. So go to lunch and come back at 7:45.